All right, who's on first? Ready for map display? Shapefiles, choropleths, and labels. We've talked a few times, Aaron Srepcope and I, about who's on first. At its core, it's just a list of places, a very big list of places, each with a stable identifier, so it's easy for computers to reference those places. And it has descriptive properties like Oakland, California, or Tacoma, Washington. Each of these places has a hierarchy. Tacoma is a locality, city, town, village. It exists in a county, a region, a country, and we aggregate sources from hundreds of different places, from US Census in the US to the equivalent national mapping agencies worldwide. Who's on first is not the only gazetteer out there. Some other common ones are geonames, geoboundaries, and GATM. Some of these are academic projects. Some of them are semi-commercial. I like to think that Who's on First is in that sweet spot where we kind of play to the strengths with unique identifiers. We have free polygons, and we take a special care with internationalization and localization. So I'll talk a little bit more in this presentation about two of these aspects, polygons, and then we'll get into map labels. So over the last couple years, we've made it a lot easier to use Who's on First. You can download it in shapefile format now and quickly make a map like this, US counties and population density. So let's talk about how you can do that. You can download from who'sonfirst.org now, and also a QGIS plugin. So you don't have to find the website. You can just point and click in the software and get the data. So let's walk through that. In QGIS, you can manage plugins. You can search for this plugin by name, HCM GIS. It's a very popular plugin, so we just added some functionality to download Who's on First data by country. You can install that plugin. A new menu becomes available. You can download open data from Who's on First. You can choose a country, in this case, the United States. Some countries have a lot of data. US is about half a gig. A small country like Andorra will be more like 1 or 2 megabytes. The data will load over a minute or two, and it'll splat into your table of contents with your typical GIS color scheme. We can turn a few things off, and each of these features has a small set of attributes. In Who's on First, we have hundreds of attributes that can be a little overwhelming, especially in the SQL files. The shapefile just includes a couple dozen attributes. One of them is population. We have that for a lot of places around the world, especially if you're in Europe and North America. But I'd like to call attention also to this concordance key and concordance ID. In the US, we would use US Census GeoIDs. My home county is 06, 023. 06 is for California, 023 is for Humboldt. Each of these counties has that ID, so if you want to join it with other census statistical data, it's very, very easy, and this is available in around 45 countries now. Before I talk about map labels in all the places at all the zooms, I'd like to talk about the data a little bit more. You can pull up the bit.ly link, bit.ly WOOF map, to play with this for your own city. We'll come back to that. So after 10 years, Who's on First has ubiquitous coverage for almost all the places around the world. You can pretty much zoom into anywhere in any country and find settlement points, and often polygons for regions, states, provinces, and counties. With this project, we wanted to kind of marry the natural earth curated MinZooms with all this other data, millions of records. So it's both a top-down human curated approach and then a bottom-up kind of machine approach. In the middle, kind of in the Zoom 7 to 11 range, we've brought in additional data from NASA, European Commission, OECD, the Columbia University Project. And There's a lot of remote sensing work now where you can determine on a pixel basis if this is a dense city, a small sized town, a village, how big it is. You can estimate population from that. But these polygons, very few places have like a Hollywood sign. Most places do not label themselves in terms of visible on a map. So these projects are polygons. Sometimes they're adding names from OpenStreetMap or some other place. We developed some algorithms to do that kind of name matching between different data sets with a fuzzy distance matching as well, and with about a 60% match rate between these things. Who's on First actually has lots of different geometries, even for San Francisco. If you look at the math centroid for San Francisco, you think of the 7x7 grid of the city, of the mainland, but there's also islands way out in the sea that are part of San Francisco. If you were to do the math centroid, you would label San Francisco in the Pacific Ocean, kind of awkward. If you were to label San Francisco in the middle of that 7x7 grid, there's no skyscrapers there, so it's a little bit weird to put it there. Usually you want to label it in the downtown area, maybe City Hall. So there's a lot of different alternate geometries to parse through. So part of this work is understanding when to use area type and when to use point type and where that point should be. The general kind of workflow I took was to extract features out of that huge SQLite distribution as just a CSV, a small set of the properties, much more manageable. We brought in that natural earth curation at the low zooms. We used this other data sets to kind of do a semi-curated data for those mid zooms. And then we're looking at place types. Basically, you should label a country before a state, before a city, before a neighborhood. And some of those places are capitals of big things and small things. And then, there's a difference between like a small rural village and a bigger city. So we essentially have these different ladders of candidate zooms, and then we kind of gather that up with a few thousand lines of SQL statements. I created a custom Planet Tiler profile. Planet Tiler is a new piece of software. It's written in Java. It's made for tiling OpenStreetMap, but it allows lots of different alternate profiles. So I wrote one that takes the CSV file in as a geopackage, and for each of the tiles, it just shuffles them up and says, like, hey, let's order these features, and a tile is kind of big, so let's subdivide it into like 8 grid cells, and for each of those subgrid cells, what's the biggest, most important city here? So it takes that, it does it for all 15 zooms, and then we just do some statistics on it and saying like, hey, which is the earliest zoom this feature was allowed to actually show up after the server-side collision, and then we apply that back onto the original data set. So we're trying to take the output of something that is usually just a visual output and put it back into the database. And this runs in about 20 minutes. I can step through some examples here. This is mostly influenced by natural earth. And the idea here is to create a places layer, a vector tile places layer that you can swap in and use in any project. So the background water and kind of political boundaries are from OpenStreetMap, but all the labels here in terms of United States and Kansas and Washington State, Seattle, those are all from Who's on First. So Zoom 6 is kind of where Natural Earth version 5 maxes out. We have some manual curation that we added in Zoom 7. We had the presentation earlier today. So this is kind of where the human curation ends, and then Zoom 8 is where more the robots and I are having a dialogue, and we're mostly getting it right. So you can see Seattle and Tacoma, and just zooming in, you're starting to see those county labels pop in. some of the smaller cities around Tacoma. Zooming in some more, and zooming in some more, you finally see the neighborhoods. And these are all coming from Who's On First. And the idea here is that there's a lot of data, but how do you filter it? You can just filter it by that min zoom attribute in when you're doing the selection, and then a little bit of data comes out just appropriate for that zoom. Overall, the results are beautiful. You can check it out online, but I'd like to spend just a moment talking about we have a lot of data, but it's actually not enough data. As I've been working on this project, I estimate around 1 billion people are still not properly mapped around the world. That's mostly in Africa, South America, and Asia, and we're probably missing around 1 million localities. Which is a pretty big number. In kind of urban geography, we kind of use this number, at least in the US, of urbanization threshold of being about 2,000 people. And most of these areas are less urbanized than the US. And when you look at kind of missing localities. There's a few of them that are big cities, but I'd say the big cities are mostly well mapped. There's certainly like some big cities in China and Africa that are still missing, and kind of edge cities on the sides. But most of these places, probably 98%, are small rural villages. And there's a lot of work left. You can see these places on a satellite kind of classified image, but what is the name of that place? It's a pretty big focus area going forward. When we did some projects in India, we saw that we could add 400,000 missing places, looking at national government data that was coming available, and that urbanization threshold drops down to about 1,500 people. And in Nigeria, we saw it drop down to around 1,000 people. And together, this is 600,000 places just in these two countries that we were able to add, using these newer kind of approaches. There's also an elephant in the room in terms of OpenStreetMap. So we did a little bit of analysis looking at Who's On First versus OpenStreetMap. Overall, pretty comparable, especially in North America and Europe. But Who's On First is doing quite well in Asia and less well in Africa and South America compared to OpenStreetMap. So it really depends, what country you're creating a map from. You should always try to, look at multiple sources, and there's some obvious areas for improvement here. So what's next? We'll be finalizing and publishing the results back to who'sonfirst.org for download, and you can all make maps out of it. The shapefiles are available today, but the min zoom and the label points will be coming soon. And there's quite a bit of work left to map these 1 billion people around the world. There's different ways to do that. There's a lot of new, both satellite-derived data in terms of population extents, but also building footprints. And we can start to kind of correlate between these different products. So really exciting time where there's big data, big processing, and I think there's still a lot of need for kind of local knowledge in this effort. It's one thing to say that there's a village there, but what is it called, and how do you spell it, in what languages? So in Who's On First, we've been thinking about not just vacuuming up kind of national mapping agencies worth of data, but kind of creating a lot more kind of web-based editing where you can go into the website, view the data, but also add missing places. So we have a little bit of that editing functionality today, and we'd love to add more of that in the future. So you can learn more about this project on the Who's On First blog. You can download the shapefiles today and preview the Slippy map of these map labels, the new places vector layer at that bit.ly link. And I now work at Applied Intuition. I'm hiring map engineers. So if you're interested in that, please talk to me afterwards as well. Thank you. Sure.
So when you two questions. When you're comparing to OSM, are you talking just coverage, or are you looking at the languages you cover, like all the different attributions? How are you comparing?
Yeah, this map just looks at the existence of places, basically the count of places by country. In OpenStreetMap, most often it's the same as in Who's on First, which is a point location. Who's on First and OpenStreetMap also have polygons, mostly in the usual suspects. So we're looking at the existence of places. If you start looking at spatial accuracy or language coverage, I'd say language coverage, Who's on First is generally better because of the crosswalk with other projects like Where on Earth versus Who's on First, if you get the joke there, but also with Wikidata and other projects. So probably localization, Who's on First is a little bit better in terms of XY accuracy. It really depends. Both of these projects have imported weird data from GeoNames and other places, so everyone has areas of improvement.
From a polygon perspective, I've had experiences with client-side rendering and polygons taking forever to load. Can you speak to that as far as did you go through an exercise of seeing how much it takes to load all those polygons?
Yeah. So for the map where we're looking at these labels, I'm trying to simplify that quite a bit and only include point geometries, even if the feature has a polygon. The points are very fast to load, and you can do localization on them as well without too much heft. So I think your question is kind of getting at hey, some of this data from the national mapping agencies is really big, a couple megabytes for an individual feature, and then if you have 20 or 30 features in view, it's very hefty on a desktop, let alone over a small pipe to a phone. We do have support in Who's on First for display geometries. The goal there is to use a tool like MapShaper to make sure that there's a small, kind of 200 kilobyte or less sized representation of that feature. So I can kind of walk you through that separately afterwards. In the back?
This is not a basic question, I'm purely curious. As an organization that's working on a gazetteer scale project, can you speak to the philosophy around disputed geographies and how you're considering keeping anywhere close to that world of updates?
Yeah, so the question is, how does a gazetteer track with disputed territories? You can look at Ukraine and other places, for example. Who's on First does have some effort that way. So at the top of the hierarchy is countries, but we also have dependencies and disputed territories. Disputed territories are an overlay on that. For the places like a city that is in a disputed territory, we'll track that it is in a disputed territory. That disputed territory has a polygon, and with reverse geocoding, there's some extra syntactic properties that say, hey, you should probably mask the parent geography here, or if you have a certain opinion that you ascribe to, then you should show that one instead. So the project does support that, but it requires a little bit of extra engineering effort to implement. One more question, Gordon?
Yeah, neighborhood boundaries. You have neighborhoods?
Yes, we do.
Who chooses the boundary? That's disputed. That's inherently disputed in most cities.
Yes, it is. So we believe that in Who's on First, it's important to be able to have all those opinions, but also to set a default kind of conventional opinion. So a lot of the neighborhoods have polygon extents. A lot of them have alternate geometries from other organizations. But generally speaking, there is a center of a neighborhood, and there's roughly the outer bounds of a neighborhood.
How about including all the versions of it? Polygons on top of polygons saying, my version of Finney Ridge, her version of Finney Ridge. They're not in agreement, but we both know we live on Finney Ridge.
Mm-hmm. Yeah.
So two polygons.
So we do have support for alternate geometries, and we do include alternate geometries for a lot of these places. We do choose to have a somewhat of an opinion about where one by default begins and ends, and we adjust those over time. Really, the project holds space for those divergent opinions, especially on a place like neighborhood, like everyone's arguing, right? But the important thing is there is a place called Finney Ridge, and it has an ID that we can kind of argue about the spatial extent of it. So it's holding space for that debate. Maybe you can find me afterwards. Thank you.
Great.